in lesson 5.5 today, which is curve sketching. Okay, we are going to be looking at, okay, dependent on what information they give me, how, what kind of curve can we sketch? Okay, what kind of graph can we sketch? Now, as we do our curve sketching, and when you get to homework, while yes, there are certain things that have to be true, certain characteristics that have to be true, does that mean there's one right answer? There's not. And that's what you're going to have to keep in mind when you do homework, that, try something on your own, but you're looking for certain characteristics. That doesn't mean there's one right answer. Okay? So, curve sketching is a big thing in this as we're working to connect our function, our first derivative, and our second derivative. Okay? So we can use these relationships to quickly sketch the graph. We already know how to find things like domain, range, intercepts, asymptotes, and we'll talk about those a little bit more. But now we're going to use derivatives to help us. Now, okay, as we look at example 1 here, it asks us to complete the table by sketching the general shape of the curve when each condition is met. Okay, so there on the left, f double prime of x greater than 0. What does the second derivative being greater than 0 mean? Okay. My graph is going to be concave up. Now, when the first derivative is greater than 0, what does that mean my graph is going to be? Okay, first derivative is increasing. So, can you draw a curve that is concave up and increasing? I personally am drawing something like that. It's increasing the entire curve. It's concave up. Now, I'm not going to say there's not other possibilities. I'm not sure.
I was just going to draw a graph with it.
Like a parabola type thing?
No, like a XY graph, and then do a...
Oh, okay. As opposed to me just drawing a random curve in the middle of the box. Fair enough. Okay. What about when f prime of x is less than 0? When the first derivative is less than 0, first derivative is negative, what's that mean? That means my original graph is decreasing. So now, concave up, so still curved up, but decreasing as you move from left to right. Basically reflect your graph there. The bottom row, the second derivative being less than 0, means my original graph will be concave down. Okay. Concave down and increasing. So now it's got to be bold down somehow. But increasing means it has to be going up at the same time. That's what I did. Again, if you have a different idea, I'm, willing to listen. Concave down, so curve downward again, but this time decreasing. So as you move left to right, your curve is, you're going down. Something like that. Okay? So it's important to be able to, not just get increasing, decreasing, but put the concavity with it as well, which is what will come up on some of these graphs that we talked about today. Okay, 2. Sketch a possible graph of the function g of x that satisfies the following conditions. Okay. Condition 1. G prime of x is greater than 0. What does that mean? Okay, so it's g prime of x is greater than 0, so we're going to be increasing on these intervals here. And g prime of x less than 0 means we're going to be decreasing on this interval here. Now, I'm going to make a couple of sign charts to kind of help me picture this, but if I make a first derivative sign chart, okay, key points, what key points did they give us? -1 and 3, yes. And what were we told? We were told the first derivative is greater than 0, so positive, between -infinity and -1, and positive between 3 and infinity, which you just told me means increasing. We were told the first derivative is less than 0, so the first derivative is negative between -1 and 3, and so then you already told me that that means decreasing. Now, with that information in mind, what's going to be happening at -1? Okay, as you change from increasing to decreasing, can you picture a max here? What's going to be happening at 3? A minimum, as you change from decreasing to increasing. And I will say, part of the reason I draw the arrows like that is because I can see a max, I can see a min. Okay? Okay, that's condition 1. Let's talk condition 2. So now we're going to talk second derivative. When the second derivative is greater than 0, what's that going to mean? It's positive, and so the graph will be concave up on those intervals. When the second derivative is less than 0, my graph is going to be concave down on those intervals, yes? Now, I think they throw an extra number in here, don't they? Because I was going to try and line this up. So they have a -3, a -1, and +3. And I was just trying, easier said than done, to line it up with what's up above a little bit. So -infinity to -3 is positive. -3 to -1 was negative. -1 to 3, positive. 3 to infinity, negative. And we talked about second derivative means concavity. So this is concave up, concave down, concave up, concave down. What's happening at -3, -1, and 3?
Probably points of inflection.
Right? Concavity is changing, so some type of point of inflection. So I'm going to write it as POI. Okay. Okay. So that takes care of condition 2. Condition 3. The limit as x approaches -infinity is -4. And the limit as x approaches +infinity is +4. We definitely dealt with these in pre-calc because we just tested over chapter 2 and they're in chapter 2 in pre-calc. I don't know that we've really talked about these type of limits. Well, we've talked about limits. When we talk about a graph and a limit approaching as x approaches -infinity or +infinity and what it's doing, those are representing horizontal asymptotes, is what's happening. Okay.
So it's bound.
Yes, pretty much. Okay. As x approaches -infinity on the left, it's going to be bounded by -4. And as it approaches +infinity on the right, it's going to be bounded by +4. Okay, so that's what it's telling us. Okay. Now, Okay, shall we see about putting this all on a graph? I know, easier said than done. I'm going to start with putting some numbers on my graph. I need to go what? -3 and 3 on my x, and +4 and -4 on my y. Okay. So, we know any values. We don't really know any values, do we?
Plug it back in.
Well, we don't have a function to plug back in. And see, that's where, is there one right graph on this? No. Okay. We're going to draw a shape that can represent this graph. But here's the deal. We don't have location other than, like Eli pointed out, this is bounded, right? So it's not going to go any higher than 4 or lower than -4. But then past that, we don't have any specific points. We get to kind of make up points here. So one thing I will probably go ahead and put on here, okay, as x approaches -infinity, this is bounded by -4. So on the left, my graph is not going to go below -4. On the right, my graph isn't going to go above 4. Now, technically, those horizontal asymptotes, yes, they go all the way across, but what's going to matter is over here on the right and down here on the left. Okay, so what's my graph first doing? Before -1, it is increasing, right? So we're going to be increasing from -infinity to -1. Along the way, what has to happen at -3? My concavity has to change. So while my graph is, generally, we're going up, yes? Not that crude looking though. We're going to start off being concave up. So kind of bold up, yes? And then around -3, we're going to change and be bold down. Okay? Now, keep in mind, where are we coming from? We're coming from the fact that we were running along here. So what I'm going to do is I'm going to start down here. I'm going to do something like this. And here's the deal. I'm going to hit in the area of -3. We don't have a y value in terms of how high or low we are. So you could be on the x-axis. You could be above it. But when you hit that x value of -3, that's your point when you need to start turning. And instead, now, as I approach -1, it's going to be bold downward. Does that make sense for a concavity change? It was bold up. Now it's bold down. I tried. I'm not great at this, but I tried to make it appear at -3. Am I increasing the whole way? Yes. So right there, we increased. We were concave up. Then we were concave down. And so that means at -3 here, right thereabouts, there was a point of inflection. Now, what's happening at -1? It's a max. So we're going to start decreasing now. And we also have to change concavity. So now we're going to be concave up. So, and all the way from -1 to 3, we're decreasing and concave up. So can you visualize what we did on the graph up above? Yes? So I'm going to have something. So this is not going to be in a smooth curve. This is going to be a sharp point here. I'm going to do something like that. Okay? And again, I don't have a specific y value on where that happened. It's just where I happen to finish drawing. Now I decreased and I'm concave up. Now what happens at 3? We're going to increase and also be concave down. So think about what that looks, and again, it's not going to be a smooth turn, is it? Because if I'm increasing and concave down, it's going to go something like that, and it's going to have to stay under 4. So it's technically going to run along that asymptote. Okay. Does your graph have to look identical to mine? Absolutely not. Are there pieces that have to match? That's the key. Okay? But there are definitely different ways you can make them match. Okay. Are there questions I need to answer here? Okay. Just thought I'd ask. At the top of that next page, was this in the notes for 5.3 or 5.4, that chart? One of them. Okay. This chart is just, they just kind of put it back in here, reviewed it. It was in the notes you had to watch on a video because I didn't actually talk about it. But you've seen me using all of these symbols already. Here's your chart that connects them. If the second derivative is positive, that means the first derivative is increasing and the original graph is concave up. Same thing with second derivative negative, decreasing, concave down. If your first derivative is positive or negative, that means your original graph is increasing or decreasing. Okay, so that's how that chart is connected there. Okay, now, can you sketch a possible graph of f given f prime? And they like to take us both ways on this. Where in this case, you have to pay attention. They're giving us the derivative, and they want us to sketch the original graph. Okay? I'm not saying you'd have to, but what it helps to do to keep my brain straight is to think about kind of like a sign chart, like what I was just talking about. So if we think about f prime here, okay? Now, do we have some key points? Key points are going to be where the graph does what?
Intersects the x-axis.
Yeah, intersects the x-axis. They didn't give me numbers here. Let's say, did I make them, in my notes, I made them A and B. Just so I have something to call them. Okay, so here, I'm going to talk about A and B. What do you notice to the left of A? To the left of A, my first derivative is above the x-axis, which makes it positive. So I need you to acknowledge that left of A, my derivative is positive. Between A and B, my derivative is negative. And to the right of B, my derivative is positive. Now, if that's my derivative, what does that mean about the actual graph? Where the first derivative is positive, my graph is going to be increasing. Where my first derivative is negative, my graph is going to be decreasing. And what's that mean is happening at A and B? A is going to end up representing a max, and B is going to end up representing a min. Are you with me on that part, or at least? Okay. Now, the other part we can talk about is the second derivative. I know we don't have a second derivative here. We don't have a second derivative graph, but the second derivative is the derivative of the first derivative, yes? Mm-hmm. So what's the derivative of this graph doing? What's my derivative doing first? What's this graph? It's decreasing, yes? And if this derivative is decreasing, that means the second derivative is negative, and thus implying concave down. Now, where does that change from decreasing to increasing? Changes at 0. Okay, so because this graph is decreasing and then increasing, that means my second derivative is negative, then positive. So that means my original graph is going to be concave down and then concave up. And what's going to be happening at 0? A point of inflection because concavity changes. Okay? Now, I will say the other fact I like to use. You guys have done a lot of derivatives at this point. What does this look like the graph of? This looks like y equals x squared. Okay? If this is the derivative graph, is y equals x squared, what's f of x going to look like? Does that answer make the question?
Please excuse this interruption. At this time, if you are a senior and you did the tenderloin sales, we have your tenderloins in the high school cafeteria, so please make your way down there to check out your bags. Thank you.
It said 2:45 to 4. Does it have to be right now? I don't know if that has to be or not. So, do you want to go ahead and go?
Yeah.
Okay. What I'm trying to get you guys to realize here is this is an x squared graph. The original graph should be an x cubed graph. Okay? So, go ahead. I'm going to keep going a little bit, but I don't know, at least part of it.
You're the teacher.
Oh, there's no easy answer here. We'll do this at least, and then that way, depending on how much time there is when he gets back,
If they're doing
we may or may, well, that's the thing, we may not, I can at least have this done with you.
all right.
Fair enough?
Yep.
Okay, so it's going to be an x cubed graph is what I'm looking. Okay, so to the left of A, my graph is going to be increasing. So we're going to increase. We're going to have a max above A. Now keep in mind, we don't know y values.
Yeah.
So this cubic graph, we don't know where it is. Okay, it's a sketch. We don't all have to match. So with that in mind, I know my graph has to be increasing and concave down. So I'm going to increase, and I'm going to be concave down until I get to A. And then at A, I'm still concave down, but now I'm decreasing. Okay? So I'm concave down still. I'm going to be decreasing. I'm going to decrease. Okay, I'm going to change my curve is not doing exactly what I want it to do, but okay. I'm increasing, concave down. I'm still concave down, but now I'm decreasing because I have a max, right? So we have a max here, well, kind of a max above A, decreasing. Now, at 0, what happens? I'm still decreasing, but my concavity changes. So this is where you should see it more start to go back up. Under B, we're looking at a min. We're done decreasing. Now we're going to be increasing, but we're still concave up. I don't know. Something like that. Okay, again, there's not one right answer. Okay, and so what I just put on here in green is the y equals f of x graph. Okay. Zeros of f prime of x may be what of f of x? So a and b of f prime of x were what on f of x? They were mins and maxes. Okay, so they may be extrema is the word I'm going to put here. Extrema being the fancy word for mins and maxes. Okay. Extrema of f prime of x. So this right here, that's an extrema of f prime of x, are possible what for f of x? Well, what did we end up having here?
Inflection point.
That would be an inflection point. So they are possible points of inflection. And notice none of this is set in stone. It's all very maybe, possibly, because it just varies. When the derivative is above the x-axis, then f of x is, so when the derivative was positive, f is increasing. When f prime of x is below the x-axis, then f of x is decreasing. If the derivative is increasing, then the second derivative is greater than 0, and so f of x is concave up. And if the first derivative is decreasing, then the second derivative is less than 0, so f of x is concave down. Okay. This is where, when you're absent, I keep teaching, so, but this is going to be awkward in the middle of a, it's different when it's awkward in the middle of a lesson. I don't know what to. I'm going to keep going for right now, and I can rewind as I need to, and I don't know. Well, my hope was to get through this page today. Without Logan out of the room, I think that was doable. And I knew this probably was going to be this tenderloin's coming our way now.
I already handed Dr. Long his, so he came to the cafeteria.
Oh, perfect. Okay. You gave the right things to Dr. Long, yes?
There's
Okay.
just 3 bags that throw into the sliders.
Okay.
And it was just make sure you give them a card with cooking instructions when you give them to them.
Forgot about
They're
the
in
cards.
there.
Okay. Will do. Okay. Let's look at the graph. Okay. So, first graph. First thing we know, we're increasing and concave down. So up until A, I have to be increasing and concave down. We'd already talked today there was going to be a max. So now,
Jake Cherry, please report back to the cafeteria. Jake Cherry to the cafeteria.
Yeah, you have a whole group of bags sitting there.
yeah,
And Jake took one of his bags and left the other. And I told him, I said, "Are you gonna go back?" Because he's in the library. I said, "You gonna go get your tenderloins?" He's like, "I already got mine."
no. Okay, so we are increasing and concave down to A. Now, at A, we're still concave down, so we're still curved down, but now we're decreasing. So I attempted, it's a little off, but there's a max above A. Now we're still concave down, but we're decreasing over to 0. Okay? 0 was our inflection point, our concavity changes. So now, we're still decreasing, but we're concave up until we hit B. At B, we tried for a min, and then now, at B, we are still concave up, but now we are increasing.
Because how do we just know it's the x cubed graph?
Because, okay, so, and here's the deal. We don't even have to know it's an x cubed graph. Because we just, right there, we had already talked about the fact that it was going to be increasing, there was going to be a max, decreasing a min, increasing a max. It's just a matter of getting the concavity in with it. But the fact that if f prime is x squared, then f would have to be some type of x cubed graph. Because if f is x cubed, then the derivative is an x squared term. Okay? So that's the way that's one of the connections I make. And next semester, when we look at integrals or antiderivatives, we'll do the opposite of derivatives. So,
Antiderivative or series?
yeah. Unit 6, 7, and 8 are all about integrals and antiderivatives. Integrals officially, but that's when integral is an antiderivative. Instead of subtracting a power, you add a power.
Sounds easy. Less negative.
I don't know. Not necessarily. Okay, Logan, you're ready for the next page. You got, and the fill in the blanks, we'd already talked about them. We just hadn't filled in the blanks. So, okay, let's see if we can make it progress on this page. Okay, so A. Suppose the graph shown above is the graph of f of x. Okay, so pretend this is an f graph for these particular questions. On what interval is f both increasing and concave up?
-5 to -2.
Okay.
4 to 6.
Okay.
That's all I got.
That's all I have. And I don't know, maybe I should save time and write these in interval notation, but -5 less than x less than -2, 4 less than x less than 6. Those are increasing and concave up. 2, on what open interval is f both decreasing and concave down?
Yeah, 6.
What is it?
-1 to 2 and 6 to 8.
Yes to the first one.
Or not 6 to 8.
I'll go with the -1 to 2.
-6.
Okay, so 6 to 8, the problem is that one's increasing. We need decreasing.
Yeah.
-8 to -5 is concave up, and we need concave down.
Sometimes when we draw half of that, it'd be considered concave.
At what x values does f have inflection points? So where does our concavity change? -2, where else?
-1. Or not negative.
No, -1 would be a max. It's not. It's still concave
Yeah.
down.
6.
2 and 6.
I agree both. 2, we're changing from concave down to concave up. 6, we're changing from concave up to concave down. Okay. Now, changing scenario. Now, that same graph, pretended it is a derivative graph. Okay, so pretend it is the first derivative. On what open intervals is f decreasing? So we're looking at a derivative graph, and we want to know where is the original graph that we don't see decreasing. So f is decreasing when f prime is what?
0.
Right, okay. So when the derivative,
So we're not supposed to look at the graph.
well, we are.
Slope of the graph.
Okay, so the question is when is f decreasing? So you're looking at when is the derivative negative,
So we can just look at when the slope is negative, right?
not when the slope is negative. This is no longer, this right here is f prime. This is no longer, but the question is about F.
So between 2 and 6.
Uh-huh. And my justification is the derivative is less than 0. So this is okay. If you're looking at derivative graph, what information can we gather about the graph it represents? Okay. Are you okay with that, Logan?
Sure.
The justifying is the derivative is less than 0. So where the derivative is negative, if we were to sketch the actual graph, it would be decreasing in that area. Okay. At what x values does f have a local max? So when do maxes happen? Max.
F prime equals 0. So 5, 2, and 6.
Okay. We could talk about.
No, when it changes from increasing to decreasing,
Yeah.
so 2 and 6.
Okay. So not 2 and 6. So maxes specifically occur when my graph goes from increasing to decreasing. Or, in other words, when f prime changes from
Whoa.
positive to
I
negative.
thought we were just talking about extrema.
Okay, no. So we only want to look at when f prime changes from positive to negative. At which of those points we mentioned does f prime change from positive to negative?
2.
And that is x equals 2. Sorry, I'm kind of doing my justify first and then my answer, but as long as it's all there. And that was specifically a max. Of course it is. On what open interval is f concave down? So it's concave down when what? When f prime is decreasing? When is f prime decreasing? -8 to -5? And I know I saw at least one other. -1 to 4. Okay? And I guess we'll just awkwardly stop there and do 4 tomorrow. So, at what x value does f have an inflection point? Well, that's going to be what? When my graph changes from increasing to decreasing. So, when f changes increasing to decreasing, or vice versa.
Are you taking us to home?
Yes, I will. Considering you're not going home till like 10 o'clock tonight, 9 o'clock tonight. I'm going to go ahead and write this down, and that way I'll be here tomorrow. Where are we changing from increasing to decreasing? -5, -1, and 4. Right? Okay.